fluid mechanics most expected question for RRB JE 2024 exam and SSC JE 2024 CVT2. So those who are preparing for RRB JE 2024 exam and also preparing for SSC JE CVT2, you can follow these classes for practice of the questions on the subject of fluid mechanics. Good evening, everyone. Good evening and welcome to the session. So I'm meeting you after a very long time, but hope all of you are fine and you are following the Resultant AJ YouTube channel for a preparation for JE level exams. Good evening, everyone. Welcome to the session. Please reply me in the chat box if you are getting the clear audio and video. Yes, good evening, everyone. Very good evening. Welcome to the session. Yes, good evening, guys. Yeah, I know that I'm meeting you after a very long time, but I can see there are 3 students there. Hello, Manoj Prabhakaran. Good evening. Manoj, you need regular classes, but earlier we used to provide regular classes, but the students were not seen in good numbers, as I can see today also. So based on that only, we've decided to reduce the classes of the so that the students are not interested to daily come in the classes. Then we have decided this to reduce the number of classes. Okay. Everything what we do is based on the response of the students. You know that this is a faculty driven institute. Everything, all the decisions are made by the faculty based on the students' response. Now, if the students' response is not that good, in the class, for example, today you see this, right now we have 3 students live in the class, right? So if we don't get a good response from you guys, then it's not possible for us to conduct the classes daily. So that's why you can see few gaps in the sessions, only to check that maybe the students who don't get regular classes at least value these classes which are happening. Maybe in 1 week we are now providing you 3 to 4 classes of technical classes. Earlier we used to provide you daily classes, but daily classes students were not following, right? You have also seen the trend. The last lecture that I have taken, fluid mechanics most important questions, the last lecture was viewed by only 139 students. Even the recorded students are not watching the sessions. Even if you see the recording of the session, that is also very less. Very less students have watched them. So because we are not getting that much good response from you guys, so what we have done, we have better utilized our energy in the paid classes, right? Because we have to also take the paid classes, paid course classes. So we are providing the teacher are basically taking the paid classes rather than taking the YouTube classes, because we cannot see good response from the students. Okay, I know that you guys want a lot of things, but if you really want few things, then you should also come in the classes. Okay, we were already providing daily classes. I used to daily take the classes every day, but the response was not that good. Please like the session, share the session, subscribe the channel and press the bell icon. This is my short description about my teaching experience, about the subjects I have taught, qualification and achievements. Let's come to question number 1. If the outlet angle of the bucket for the Pelton wheel is 60 degree, the maximum efficiency in the case of Pelton wheel, neglecting the friction in the bucket is? First of all, which efficiency they are talking about for the Pelton wheel turbine? They are talking about the hydraulic efficiency. The hydraulic efficiency of the Pelton wheel turbine. Now, hydraulic efficiency of a Pelton wheel turbine, and that to maximum hydraulic efficiency, is equal to 1 plus cos phi by 2. Now, phi is the blade outlet angle. Phi is the outlet blade angle. The outlet blade angle of a Pelton turbine is given to you as 60 degree. If you put cos 60, then cos 60 degree is half. If you put it here, you will get this answer. Okay. So you will get 1.5 by 2, and into 100 if you do, that will be 75%. Hello Renal Meti, good evening. Manoj Prakaran is, yes, your formula is correct, Manoj. Hi Deepa, good evening. I'm good. How are you? How is your preparation going for your exam? कैसी चल रही है आपकी तैयारी? How is your preparation going? Now this is another numerical from the turbine. In this question, they have given the inward flow reaction turbine. Inward flow reaction turbine has the following data. Head is given. The head available is 25 meter. Velocity of the flow is 2.5 meter per second. Hello Amar, good evening. And guide blade angle is 10 degree. Runner vanes are radial air inlet and radial at inlet. Radial at inlet and discharge at the outlet is also radial. What will be the approximate hydraulic efficiency of the turbine? For hydraulic efficiency, production and I industrial management कर रही हूँ CBT 1 के साथ. Yeah, production has a good weightage in RRB JE exam. You should prepare for the production. So what is the formula for the hydraulic efficiency? The hydraulic efficiency is the ratio of runner power to the water power, right? Now, how can you find the runner power? Runner power of a turbine is equal to, the formula for runner power is, that is rho into Q VW1 into U1 plus VW2 into U2. Okay. Okay, nice strategy, Deepa. You can follow this strategy. Prepare for production subject. It is having high weightage. At least your high weightage subject will be prepared. Okay, and industrial is also having weightage of around 10 marks at least. So at least 50 to 60 marks will be prepared. That's also a great strategy. You can follow that, and it's nothing wrong in that. And velocity of the flow is constant. So U1 is equal to U2 is equal to U, that is given to you in this question. And so because at the outlet the discharge is radial, so we can say that runner power will be rho into Q VW1 into U1. Okay. Now in this question they have given few things. How to find the value of hydraulic efficiency. The hydraulic efficiency will be equal to rho into Q VW1 into U1 divided by rho G QH. What is rho G QH? This is a formula for water power. Water power is rho G QH. So rho will get cancelled out. Okay. It is going to get cancelled out. Discharge is going to get cancelled out. You will get this as VW1 U1 by GH. Now, this is a formula for hydraulic efficiency. Now, you know what is U1. U1 is equal to 2.5 meter per second. But you don't know the value of, sorry, not U1. This is not U1. This is VF1. In this question, they have given the value of VF1. The velocity of the flow is equal to 2.5 meter per second. How to solve this question? In order to solve this question, you have to draw the velocity triangle. If you see the velocity triangle of the inward flow reaction turbine, I will be drawing the inlet velocity triangle. In the inlet, this is V1. Okay. If this is V1, this is alpha 1 is equal to 10 degree, and this is VF1 is equal to VR1, and this is U is equal to VW1. Okay. So tan alpha will be equal to Vf1 divided by Vw1, and U is equal to Vw1. Okay, hello Neeraj, good evening, welcome to a session. So tan alpha is already given to you. Sorry, alpha is given to you. You can get the value of Vw1. So Vw1 will be equal to Vf1 is 2.5 divided by 10 degree. Okay, so you will get Vw1. So Vw1 we will get as equal to 14.28, and that is also equal to U1. Okay, so you just find the hydraulic efficiency from here. Hydraulic efficiency will be equal to 14.28 into 14.28 divided by 10 into H is 25. When you solve it, you will get the hydraulic efficiency, that is approximately 81.5%. 81.5 or 81.6 you will get. Clear to everyone? Is it clear to everyone? Understood the question? Understood the question, everyone? Hey, hello Neeraj, good evening. So U is equal to Vw1. Okay, in this question. बहुत सर से यस बहुत सर से बात होती है दीपा, यस आप भी बात कर सकते हो बहुत सर. इट्स नॉट, अभी तो उनकी ट्रेनिंग चल रही है, अभी तो ट्रेनिंग में तो इतना अभी वर्क नहीं है. रेगुलर इनकी क्लासेस होती हैं सर की, सो उसमें क्लास अटेंड करनी होती है सर को बस. बट आफ्टर 6 मंथ ट्रेनिंग उनको एलोकेट किया जाएगा कहाँ पे उनको जाना है. सो अभी आप इफ यू वांट टू हैव एनी डिस्कशन विद बोथ सर, यू कैन डू दैट. ही विल गाइड यू हाउ ही इज प्रिपेयर्ड फॉर RRB JE. Understood question, everyone? Next question, the head loss due to friction for the flow of water through penstock can be minimized by. How can you minimize the head loss due to friction when the water flows through the penstock of a turbine? Yes? How can you minimize that? टेलीग्राम से भी कर सकते हो आप बात. नंबर तो मैं शेयर नहीं कर सकता, जब सर से पूछ के ही कर सकता हूँ मैं. एक बार मैं सर से पूछ लूंगा, नहीं तो आपको मैं टेलीग्राम पे शेयर कर सकता हूँ. यस, व्हाट इज द आंसर? हाउ मेनी ऑफ head loss due to friction? See, head loss due to friction is equal to FLV square by 2GD. Now formula is going to remain same now. This is the formula for head loss due to friction. Head loss due to friction is minimized. How can you decrease the head loss due to friction? If you want to increase the length, increase the length. If you increase the length, this is going to increase. If you increase the diameter, then it will definitely decrease. So the right answer will be option B, increasing the diameter of the penstock. Okay. टेलीग्राम का लिंक, मेरा टेलीग्राम और बोस सर का तो टेलीग्राम तो नहीं है. आप मुझे मेरे पुराने टेलीग्राम से ही कर सकते हो, मैकेनिकल बाय विकास भदौरिया. यू कैन कनेक्ट मी फ्रॉम हियर. Okay, I will message you, you can personally message me, and मैं बहुत सर से बात कर लूँगा. अगर सर अपना नंबर शेयर करने को बोलेंगे तो मैं आपको शेयर कर दूंगा सर का नंबर. Okay. An impulse turbine produces 50 kilowatt of power when the blade mean speed is 400 meter per second. What is the rate of change of momentum tangential to rotor? Yes. So the power is given for the impulse turbine. The power is given. The mean blade speed is also given. How to find the rate of change of momentum? Yes, tell me everyone. Yes, come on, response everyone, response. So there are few questions I'm taking. Sir, आप भी कर रहे हैं? नहीं, मैं नहीं कर रहा दीपा. I am not preparing for RRB JE. RRB JE कर सकता था, बट मैंने फिर अब मैं एक्चुअली कर नहीं पाऊंगा. मतलब मेरे पास टाइम थोड़ा कम मिल पाता है. आई हैव टू फुली फ्लेज प्रिपरेशन, क्योंकि मेरे सब्जेक्ट सी विथ यू गाइस देयर इज एन एडवांटेज कि आप लोग सब सब्जेक्ट्स पढ़ते रहते हैं, एंड बिकॉज ऑफ दैट आप लोग के काफ़ी प्रिपरेशन हो रखी है. मेरे साथ ऐसा है कि आई एम नॉट मैं कुछ सब्जेक्ट ही पढ़ाता आया हूँ और उसी में मेरे को थोड़ा बहुत नॉलेज है. सो इफ़ यू कंपेयर योर प्रिपरेशन विथ माई प्रिपरेशन, आई एम नॉट हैविंग दैट मच गुड प्रिपरेशन लेवल. ओके, सो मेरी प्रिपरेशन का लेवल और आपकी प्रिपरेशन का लेवल थोड़ा अलग है. आपको ज़्यादा अच्छे से सारे सब्जेक्ट्स आते हैं. Yes, how to solve this question? Many of you are giving option as 125, option D, Amar and Neeraj. Yes. How have you solved this question, Amar and Neeraj? What concept you have applied? What concept you have applied to solve this question? Power is given to you. The blade speed is given. So you will apply this concept that power is equal to force into velocity. Okay, simple concept. And you know power is equal to 50 kilowatt, 50 into 1000 watt, and that is equal to force into velocity. Velocity is 400. Okay, and from here you will get the value of force, that is equal to 125 Newton. And you will say, no sir, they are asking about the rate of change of momentum. You know that according to Newton's second law of motion, you know that force is equal to rate of change of linear momentum, right? So rate of change of momentum is nothing but it is equal to force, and they are asking the force. Yes, very good. See, the reason I have asked this question to you guys, because I want to see what concepts you are applying. Okay, very good. Which of the following components of reaction turbine increases the head on the turbine by an amount equal to height of the runner outlet above the tail race? Understand the question. Which of the following components, draft tube, guide vanes, scroll casing, moving blades, they increase the head on the turbine above the tail race and at the runner outlet, right? Above the tail race, this is the tail race, okay, and just above the tail race we use this kind of device which is having increasing area, and this is basically at the outlet of runner. This device is installed which is having increasing area, and you call this device as draft tube. And with the use of this device, the kinetic energy which is there at the exit of the reaction turbine, that can be converted into pressure energy. Okay, and it also increases the head, overall head. Very good, draft tube. Mean diameter of runner of a Pelton turbine is 200 mm and least diameter of the jet is 1 centimeter. Calculate the jet ratio and number of buckets. Number of buckets, not brackets. In Pelton turbine, the mean diameter is given to you. This is a question from construction of a Pelton turbine. Okay, so construction based question. So let's try to solve this question, everyone. Yes. So you know that what is formula for jet ratio? Jet ratio is equal to ratio of diameter of runner to the diameter of jet. Okay, so you can easily find this. So now this is 200 mm and this is 1 centimeter, and that can be equal to 10 mm. So this is simply 200 by 10 mm. So you will get this value as 20, right? Now number of buckets, what is the formula for number of buckets? The number of buckets of a Pelton turbine, the formula is it is equal to 15 plus diameter of the runner to the 2 times the diameter of the jet. If you put it here, you will get this formula, 15 plus 20 by 2. Okay, so you will simply get this value as 25. So 20 comma 25. Very good. Next question. Consider fully developed flow in a circular pipe with negligible entrance length effects. Assuming the mass flow rate, density and friction factor to be constant, if the length of the pipe is double and the diameter is half, the head loss due to friction will increase by a factor of. Head loss due to friction has many formulas. You can write this formula FLV square by 2GD. You can use this formula FLQ square by 12D power 5. Okay. Now, for fully developed flow in a circular pipe with negligible entrance length, assuming the mass flow rate, density and friction factor to be constant. Okay, so mass flow rate or discharge, density and friction factor is constant, the length of the pipe is double, the diameter is half, the head loss due to friction will increase by a factor of. Yes, come on, tell me how to solve this question. There is also one formula for head loss, that is 32 mu VL by rho G D square. This is also one formula. But in this formula, this is not the formula of with respect to discharge. Okay, this formula is not with respect to discharge. That's why we cannot use this formula. So we need to use a formula which is having the relation of head loss with the length and diameter. With the length and diameter, the head loss can be this, right? Length is double, that is L2 is 2 times of L1 and diameter is half, D2 is D1 by 2. So head loss due to friction, head loss will be due to friction will increase by a factor, that is HF2 by HF1 will be equal to what? Tell me. That will be L2 by L1 into D1 by D2 power 5. L2 by L1 will be 2L1 by L1 and D1 by D2, that is 1 by 2, sorry, not 1 by 2, D1 is 2 times of D2. So it will be 2 into D2 by D2 power 5. Okay, so this is going to get cancelled out. You will get 2 power 5, 32, 64. So 64, you will get how much it is going to increase by 64 times. So head loss is going to increase by 64 times. Okay. Now there were 3 options. You could have used this formula, you could have used this formula, you could have used this formula. Why we have selected this formula? Why? The reason is क्योंकि यही फॉर्मूला आपका रिलेशन बताता है. दिस फॉर्मूला ओनली टेल्स यू द रिलेशन बिटवीन द हेड लॉस एंड लेंथ एंड डायमीटर, द क्लियर पिक्चर, राइट? द वेलोसिटी अलोंग द रेडियस ऑफ अ पाइप ऑफ 0.1 meter radius varies as velocity is equal to 10 into 1 minus r by 0.1 whole square. This kind of relation is given. Viscosity is equal to, viscosity is 0.02 Newton second per meter square. You have to find the maximum value of shear stress. How are you going to find this? Now you can see that velocity along the radius of a pipe of 0.1 meter radius varies as this. This is the relation of the velocity. Now can you compare this relation with this relation? U is equal to U maximum 1 minus r square by r square. Okay, we can compare with this relation. Or you can compare it with this relation, u is equal to u max 1 minus r by r whole square, right? Now, what is the formula for maximum value of shear stress? Maximum shear stress is equal to minus of del P by del X R by 2. This is the formula for maximum shear stress. Okay. Now question is how to find the maximum shear stress. Now this maximum velocity, if you compare, the maximum velocity is equal to 10. Maximum velocity by comparison will be equal to 10. And the formula for maximum velocity is minus 1 by 4 mu del P by del X R square. Right? Clear? So from here you can get the value of, you can see what you need to find. You need to find this. You need to find the value of this. So how to find the value of this? Tell me. From here you will get that del P by del X R square will be equal to minus 40 mu, right? Are you getting this, everyone? Or you can say, if you know the value of R is known to you, radius of the pipe is known to you, so you can get the value of minus del P by del X from here. Minus del P of del X will be equal to 40 by 0.1 square. So you will get this value and you can put it here, minus del P of del X into R by 2, and you will get the answer. So what will be the answer? Tell me quickly. So this will be 4000. Okay, so you will get this value as 4000 into 0.1 by 2. Okay. I think I have done some mistake here. Huh? Sorry. One more thing will be there. Yes, there is mu also. Mu. Sorry. Into mu also. Into mu. How much? What is the value of mu? 0.02. So you will get this value as 80. So you will get this as 80 into 0.1 by 2. Okay. So you will get this value as. Now question is, you will get this value as 4. Okay. So either you can say minus 4. I have taken this value as minus del P by del X. So del P by del X will be equal to what? It will be minus 80. So you will get this value as minus 4. Okay. Minus 4 shear stress. Next question. A cubical wooden block of edge 100 mm and weight 1 kilonewton sliding down on an inclined plane of inclination 30 degree with the horizontal. Okay. So we have an inclined plane and we have a cubical block. Okay. A cubical block is there and it is sliding down the inclined plane. This is inclined plane is the angle of 30 degree. This is the weight of the plane. Sorry, weight is 1 kilonewton. So obviously it will be having two components. If you resolve it, it will be having two components. Okay. This is 30 degree. So this will be 1 kilonewton cos 30 degree. And this will be 1 kilonewton sin 30 degree. Okay. So you know that obviously the inclined plane is going to move downward, right? So this is a force which will be acting. Now shear stress is equal to mu You have to find in this question the value of terminal velocity. Now shear stress is equal to mu du by dy, right? Shear stress is equal to shear force per unit area, that is mu du. Now instead of writing du, you can write v. Instead of writing dy, you can write value of this 0.02 mm. So 0.02 10 power minus 3. You have to find this value of terminal velocity. Mu is given to you in this question. This force will be equal to how much? This force will be 1000 into sine 30 divided by area. Area will be 0.1 into 0.1 is equal to mu, that is 0.2 into v by 0.02 10 power minus 3. If you solve it, you will get velocity. What is the terminal velocity? Tell me, everyone. Solved it, everyone? Please solve it and tell me the answer. Five. Many of you are giving answer as 5. Okay. Are you sure the 5 is the answer? Okay. So 5 पे ही लॉक कर देते हैं. So the right answer is 5 meter per second. Very good. Next question. If a pipe contains an oil of specific gravity 0.9 and a differential manometer connected at the 2 points A and B shows a difference in the mercury level as 15 centimeter, then difference of the pressure at 2 points will be. Difference of the pressure. How you will find the difference of the pressure? Come on, tell me, everyone. Try to solve it. So I am taking all types of questions. Okay. I'm trying to take all the types of questions. So we have a differential manometer. Obviously, differential manometer is used to find the pressure difference between two sections of a pipe. So it will be somewhat like this. कुछ इस तरीके से होगा. डिफरेंशियल यूट्यूब मैनोमीटर डिफरेंस ऑफ प्रेशर मेजर करता है दो सेक्शन पे. ओके, पाइप के दो अलग अलग पाइप हैं. लेट्स से देयर आर टू डिफरेंट पाइप्स एंड यू वांट टू मेजर द डिफरेंस ऑफ द प्रेशर, राइट? Pipe A and pipe B. Now in this question they have given that this value, difference in the mercury level, this is 15 centimeter, this is given to you. So how to solve this question? Tell me. Yes. So pipe is having oil. So specific gravity here is 0.9 and obviously it is having mercury here. The specific gravity of the fluid in mercury, that will be equal to 13.6. Okay. Yes, many of you are giving the answers. Very good. All right. So when you solve it, you will get this value as the difference of the pressure PA minus PB will be equal to, yes, very good, that will be equal to 15. 15 is 0.15 into specific gravity of the 13.6 divided by 0.9 minus 1. So you will get the value of this pressure difference from here, PA minus PB by rho G. Okay, and from here, because both the pipes are having the same liquid, having specific gravity 0.9, so you will get this value, PA minus PB by rho G, something value you will get from here, and then you will multiply this with 900 into 9.81 into 0.15, 13.6 by 0.9 minus 1. You will get difference of pressure, which is 18688. Okay, option C. Are you all getting this value? Tell me, everyone. $18688.05. Okay, you must be thinking, sir, why are you multiplying with 900? Why are you multiplying with 9? Because we are finding the pressure difference between the pipe. Now in the pipe, the fluid is having a specific gravity of 0.9. So density of the fluid in the pipe will be 900. So we'll be using 900 kg per meter cube as density, not 13600. In a differential manometer, a head of 1.8 meter of fluid A in limb 1 is found to balance a head of 0.9 meter of fluid B in limb 2. So because this differential manometer is balancing the head, so we can say this is a differential manometer. When the head is balanced, obviously the pressure will be same. If the head is balanced, the pressure will be same, na there. So at this point, let's say this is A, this is B. So pressure will be same here, na? Right? So here the pressure will be same. So whatever is the pressure here, same will be pressure here. Now pressure is equal to, you can write rho A into G into HA is equal to rho B into G into HB. Or you can also simply write, instead of using G, you can also write that ratio of specific gravity of A and B, or density or A of B, will be equal to HB by HA. So HB is 0.9 by 1.8. Okay, so you will get this value as 0.5. Are you all getting this value as 0.5? Tell me, everyone. Next question. Air having density of 1.2 kg per meter cube and the kinematic viscosity as 1.5 into 10 power minus 5 meter square per second, flow over a flat plate with a free stream velocity of 2 meter per second. The wall shear stress of a location 15 mm from the leading edge. So we have a flat plate, and on the flat plate a free stream fluid is flowing. Okay, so the air is flowing over this flat plate. The velocity of the free stream is 2 meter per second. Okay, this is the leading edge of the plate. Obviously, when this air is going to flow over this plate, a boundary layer will be formed like this. So it is saying that the wall shear stress of a location 15 mm from the leading plate. So let's say this is 15 mm. So here the shear stress, wall shear stress, is equal to tau W. This distance, this is 15 mm. What is the wall shear stress of a location 30 mm from the leading edge? So at 30 mm from the leading edge, what will be the wall shear stress? Now you know that the wall shear stress is inversely proportional to square root of x. What is the x? X is the distance from leading edge. This is the formula. So the relation between the shear stress and the distance from the leading edge is this. Okay. So tau 2 by tau 1 will be equal to square root of x1 by x2. So it will be simply equal to square root of 15 by 30 or 1 by square root. So tau 2, that is at this point it is tau 2 and here it is tau 1. Tau 2 will be equal to tau 1 by square root 2. Okay. Clear to everyone? So the right answer is option D. Clear to everyone? Remember this relation. The relation between the wall shear stress and the distance from leading edge is this, where x represents the distance from leading edge. Okay. This is a relation important. It can be asked in some exams also. Next question. For a two-dimensional incompressible flow having velocity components u and v in x and y direction respectively, the expression, this expression can be simplified to. How can you write this expression? Yes, come on everyone. So this is the expression del by del x of u square plus del by del y of uv. So if you differentiate this del by del x of u square, you will get this value as 2 times del u by del x, plus if you differentiate this uv, this is called product rule. So if you apply the product rule, you will get this as u del v by del y plus v del u by del y. Now 2 times del u by del x can be written as del u by del x plus del u by del x, and you can write this as, sorry, I have done a mistake. This is not just 2, this will be 2 u del u by del x, which can be written as u del u by del x plus u del u by del x plus u del v by del y plus v del u by del y. Now, because it is a case of two-dimensional incompressible flow, for two-dimensional incompressible flow, continuity equation is del u by del x plus del v by del y equal to 0. Why? This is called continuity equation in two-dimensional incompressible flow, right? So now if you see this equation can be written as u del u by del x plus u del u by del x plus del v by del y plus v del u by del y. This is 0. This term is 0 na? So this term will become 0. So you will get u del u by del x plus v del u by del y. U del u by del x plus v del u by del y. This will be the answer. Clear? Understood everyone? Have you understood this question? Tell me everyone. It's not a tough question. Little bit of differentiation we have used and we have got the result. Next question. Which of the following is responsible for eddy viscosity in a turbulent boundary layer on a flat plate? There are different types of stresses. If you see in case of turbulent flow, there are different types of stresses. Okay. But which of the following stress out of Reynolds stress, Niggard stress, Prandtl stress is responsible for the turbulence eddy viscosity? So in case of turbulent flow, eddy viscosity is because of Reynolds stresses. Okay, there are different types of stresses responsible for eddy viscosity, for viscosity, but turbulent viscosity is because of the, or eddy viscosity is because of Reynolds stresses in turbulent flow. If the velocity distribution is given by this, velocity distribution is u by v is equal to 1 minus y by delta, then you have to find the value of momentum thickness. How to find momentum thickness? Now momentum thickness theta is equal to 0 to delta of u by u infinity 1 minus u by u infinity dy. Now u by u infinity, or you can say this is u by v, that is equal to what? 1 minus y by delta into 1 minus y by delta dy. Okay. If you open it, you will get 0 to delta of 1 minus y by delta into, this will become 1 minus 1 plus y by delta. This is going to get cancelled out. You will get this value as 0 to delta of 1 minus y by delta into y by delta. You solve it, you will get this value as y by delta minus y square by delta square. Okay. Now y by delta, if you integrate, you will get y square by delta, y square by 2 delta minus, this will be y cube by 3 delta square. Now when you solve it, if you put delta here, if you put 0 to delta limit, this will become, momentum thickness will become delta by 2 minus delta by 3, which will give you delta by 6. Okay, when you integrate. Clear to everyone? Because when you put the limit, this will become delta square by 2 delta. This will become delta cube by 3 delta square. When you solve it, you will get this. Clear? Next question. Consider a cylindrical body immersed in a fluid flow. The flow around the body is steady and laminar. Which of the following statements best describe the nature of the drag and lift forces on the cylinder? If you study the concept of drag and lift forces, you should know that what is responsible for the drag force and what is responsible for the yes. So the right answer is option D. The drag force is basically due to pressure drag and the lift force is due to vortex shedding. Okay, so that's the reason for drag and lift forces. Next question. According to Prandtl mixing length theory, the turbulent shear stress, what is the formula for turbulent shear stress according to Prandtl mixing length theory? There are different theory for shear stress in turbulent flow, and which of the following theory is responsible for Prandtl mixing length model? How can you write the turbulent shear stress? Yes. How can you write the turbulent shear stress according to Prandtl mixing length model? So according to Prandtl mixing length model, the turbulent shear stress can be written as the shear stress, the turbulent shear stress is equal to rho L square into du by dy. Okay, So this is the answer, rho L square du by dy, that is option C. Option D, many of you are marking option D as the answer. But according to Prandtl mixing length theory, the turbulent shear stress is equal to rho L square into du by dy. Okay? Option C will be the right answer. Many of your rho L square du by dy whole square, sorry. It will be du by dy whole square, sorry, option D. Yes. Option D will be the right answer. Very good. So what is Prandtl mixing length? Normally, the turbulent shear stress, according to Reynolds, he says that the shear stress, the turbulent shear stress according to Reynolds is equal to rho into mu dash into v dash. U and v dash are called as turbulent velocity. Okay. Now, or we can say u dash and v dash are called fluctuating velocity in turbulent flow. Fluctuating velocity. Okay. Now, according to Prandtl, what Prandtl did, he said that this velocity, the fluctuating velocity u dash is equal to L du by dy and v dash is equal to L du by dy. Okay, as per the Prandtl, these are the velocity. Now, if you put these velocities here in this formula, you will get shear stress is equal to rho L square du by dy whole square. Understood? That's how you get this. ओके दीपा, नो प्रॉब्लम, कोई बात नहीं, आप सेशन को देख लीजिए, आप वैसे देख के आप कंसेप्ट को समझ लीजिए, बाद में आप कर लेना. ऑलराइट. Vacuum pressure of 25 kilopascal is measured at a location in Shimla. So there is some place in Shimla where the vacuum pressure is 25 kilopascal, where atmospheric pressure is 77 kilopascal. Determine the absolute pressure. How can you find the absolute pressure? क्वेश्चन के सवाल आंसर नहीं दिए. कोई बात नहीं. आज की मेरी क्लास के बाद अब नेक्स्ट क्लास मेरी होगी 23 को शायद. ओके, सो माय नेक्स्ट क्लास विल बी ऑन 23rd आई गेस. ओके, सो कोई बात नहीं. आप लोग ये ध्यान रखना कि जो क्लासेस हैं अब रेगुलर नहीं है, वैसे जैसे पहले हुआ करती थी. तो एंड इतना परेशान होने की बात नहीं है. ओके, बस जस्ट फॉलो दी क्लासेस. ओके, प्लीज़, लाइव और रिकॉर्डेड, जैसे भी आप क्लासेस को फॉलो जरूर करें, वेदर इट इज़ अ लाइव क्लास और रिकॉर्डेड क्लास. जस्ट अ सेकेंड. Alright. Now, how to solve this question? You know that absolute pressure. I have also my fast tomorrow. Okay, I can understand. I have also my fast. Absolute pressure, atmospheric pressure plus gauge pressure. Now, this is the formula. Now, you know that gauge pressure can be positive and can be negative. If it is negative, it is called vacuum pressure. The negative gauge pressure is called vacuum pressure. Vacuum pressure is negative gauge pressure, right? Now, absolute pressure will be Absolute pressure is atmospheric pressure. Atmospheric pressure is 77 plus gauge pressure. Now gauge pressure is this negative gauge pressure, which is vacuum pressure. So what should we do? Should we add 25 or subtract 25? Tell me. This gauge pressure, this is vacuum pressure, is negative gauge pressure. Negative gauge pressure. What should we do in this case? Should we add it or subtract it? No problem. आप लाइव रिकॉर्ड कैसे भी देखो, ठीक है। बस ये कि जैसे क्वेश्चंस आप लोगों के लिए जब निकाल के लाए जाते हैं तो एटलीस्ट आप इनको भी देख लोगे तो आपके कंसेप्ट रिवाइज रहेंगे। ओके, नाउ ऑब्वियसली इफ यू सी द ऑप्शंस, ऑल द ऑप्शंस आर मोर देन 77. So from the option, what do you think? What should we do? And one more thing, you have to find the absolute pressure in mm of mercury. You don't have to find absolute pressure in kilopascal. You have to find mm of mercury. So how you will solve the question? That means you have to find pressure head. That is absolute pressure head you have to find. Okay, so how to solve it? 389. Who's giving 389? Neeraj Kumar. So Neeraj Kumar is giving the answer is 389. Okay, should it be 389? Okay, so you know that vacuum pressure is a negative pressure, so they will obviously put minus here. This will be 77 minus 25, which will give you 52 kilopascal. Okay, and now you need to find the pressure head. So you need to convert this kilopascal into mm of mercury. So how you will do that? So this will be 52 kilopascal, that is 10 power 3 pascal, divided by, now you have to find mm of mercury. So density of the mercury will be 13600. That is density of mercury we have to use into 9.81. So when you solve it, you need to do one more thing. You have to find in mm of mercury. So in order to find mm of mercury, you have to multiply with 1000. You will get 389 mm of mercury. Okay, so the answer will be option D. Clear? So Neeraj, you have given option D as the answer, but rest other students understood? Clear? If y is the distance from a surface, u is the velocity and u is the free stream velocity, then which of the following are the boundary condition for velocity profile over a flat plate? Now for a flat plate, you know that when a fluid is flowing over a flat plate, it will definitely near the flat plate a boundary layer will be formed, and in the boundary layer some velocity gradients are present like this. There will be velocity gradients present in the boundary layer. Now what are the boundary conditions? This is the boundary layer. Okay, so boundary conditions are, let's say this is delta, boundary layer thickness. At y is equal to 0, u is equal to 0. This is called as no slip condition. You all are familiar with the no slip condition? Good evening MS, good evening, welcome to a session, no problem. And obviously at y is equal to 0, u is equal to 0, and du by dy has some finite value, it is saying that. Okay, is it so? Will it be having some finite value? it will be having, that is velocity gradient will be having some value at least. There will be some velocity gradient here at this point. Here at this point you will be, this is called no slip point, okay, at the surface. At y is equal to delta, that means when y will be equal to delta, at this point u will become equal to u. U is the free stream velocity, okay, or we can say 99% of free stream velocity, okay. So yes, this is correct, and du by dy will be 0. This is correct. At y is equal to delta, u is equal to u, du by dy, no, it will not be having any finite value. It will, what do you think? Will it be 2 and 3 or it will be 1 and 2? But 2 is 100% correct. 2 is 100% correct. Tell me, what will be the answer? These are all previous year questions, important previous year questions, and I want all of you to Neeraj and Renault is saying option A as the answer. All right, so at y is equal to delta, this is the right condition. So see, if this is correct, this cannot be correct, okay, any one of them can be correct, na? So third is not correct, so that's why the answer will be option A, okay, because at y is equal to delta, u is equal to u, and velocity gradient will be 0, and this statement is saying that at y is equal to delta, u is equal to, and du dy has some finite value. How these two can be correct? एक स्टेटमेंट ये कह रहा है कि du by dy 0 होगा और एक कह रहा है फाइनाइट वैल्यू होगा. बोथ आर बेसिकली नॉट both the statement are contradictory. Okay, that's why this third can be not be correct. So the right answer is 1 and 2. Very good. The discharge of water through a broad crested weir of width 6 meter. Now this question came in HPCL exam and in the mechanical syllabus. In that weir, you know that notches and weir are not in the syllabus, but sometimes they can ask you a question. In HPCL paper, the question came from the notch and weir. You have to find the specific energy of the flowing water. Yes, how to find the specific energy? Come on, tell me everyone. Tell me everyone quickly. We are just going to end the session. This is the last question for today's session. Come on, tell me. So the specific energy will be 1.342, option A. And how to solve the specific energy? The specific energy will be, specific energy is equal to, that is equal to H plus V square by 2G. Okay. Now, first of all, we need to find the value of H. Now, H in this question is given. Depth is given, so H is already given, that is equal to 1.2 meter, and you need to find velocity. How will find velocity? Discharge is given. Discharge is equal to area into velocity. Okay, and what is area? Area is equal to width into height into velocity. Discharge is 12, width is 6, height is 1.2 into velocity. You will get velocity from here. So what is the value of velocity? Tell me. You will get 1.67 meter per second. Okay. Now just put it here. You will get 1.2 plus 1.67 square by 2 into 9.8. Solve it, you will get 1.34. Okay. Birmingham, I think these are something which is not related to mechanical. I have never studied this Birmingham wire gauge. Raj, so my dear, I have not studied these things. I think this is not something that I have taught. Okay, let's take this as our last question. Based on the following two statements related to manometer, select the correct option. Okay. A piezometer tube can measure the pressure in a container that is lesser than atmospheric pressure. Wrong. A piezometer measures positive pressure. It only measures the positive pressure. Okay, not negative pressure. You cannot measure the negative pressure. So pressure less than atmospheric pressure is not possible. In case of simple U2 manometer, if the pressure has to be measured, is high, then a lighter gauge fluid is preferred, and if the pressure is low, heavier is preferred. This is also wrong because both of the things have been interchanged. Okay, in case of simple U2 manometer, if the pressure is measured to be high, then a heavier fluid is preferred. And if the pressure is low, then lighter is preferred. So everything is just interchange here. So what is the right answer? Both statement A and B are incorrect. Both the statement are incorrect. Okay. Rest of the questions I will take in some other sessions. Thank you so much for joining me for this session. If you have enjoyed the session then or like the questions taken in for the session, please do not forget to like and share it, and also subscribe the channel. Press the bell icon which is next to the subscribe button. Okay. Thank you so much. I will see you in my next session will be on 23rd. Okay, so my next session on 23rd of October. I think 23rd, yeah. So you will come to know, and that session will be on thermal and applications. Thermal and applications, most expected questions. Okay, thank you so much for joining you for this session. I'll see you in some other sessions on 23rd of October. Till then, take care. Have a nice day. Good night, everyone. Thank you so much.